Hey class, welcome to Hyperbolas, which is section 10.5. So our objective in this section is the same that we've been doing all chapter, which is we're going to graph hyperbolas, and we're also going to create equations for hyperbolas. You're going to be so happy because these ones we're not going to do translated. We're only doing hyperbolas at the origin in Algebra 2. So all the hyperbolas that we do in our class will be centered at 0, 0. Okay. We will make some pictures here, but before we do that, let me give you the equation. So, a hyperbola equation looks very similar to an ellipse equation. The only thing that's different is that there is a minus sign in between instead of a plus sign. And that's also how we can determine the difference between a hyperbola and an ellipse. Otherwise, it looks exactly the same. And you know what's kind of interesting? So basically, a hyperbola is an ellipse that's just flipped the other way. So instead of, I'm just going to show you really quick, you don't have to write this down, but an ellipse has two pieces that are kind of centered towards each other. A hyperbola has the same pieces, only they're going that way instead of inwards towards each other. That's how I remember that hyperbola is the one with the minus sign. It's kind of like going, it's like subtracting each other, I guess. That's not technical, just kind of my personal way of remembering it. And I want to tell you that if you have the x squared that's first, or actually really what's happening right now is x squared is positive and the y squared is negative. There's something called the transverse axis is horizontal, but my graph is going to open left or right. Left and right, I should say. And then if you have instead a positive y squared, so then we switch it so that y squared, the positive one, always comes first. So here I have a positive y squared. Then it's going to open up and down. And I'm now going to show you a graph to example each one. Okay, so first of all, the one that opens left and right, I kind of remember this because eventually my graph is going to go on the x-axis like that and that. But we're going to be a lot more exact than that. So here's how I do this. Right now, I can find something called the vertices, the same way we did in other sections. So I would take the square root of a squared, or whatever number is right there, and plus or minus that value is going to be the value of my vertices. And those are going to go on the same axis as a variable that is positive. So if x is positive, my vertices go on the x-axis. So here I have a, comma 0 and negative a, comma 0. And now, I want to tell you that this is kind of strange, but we don't have covertices here. We only talk about the vertices, and the vertices are where my graph goes through. I will graph the other point, but I don't call it a covertex or anything. It's just, here it is. It's the point 0b and 0, negative b. And I find b by taking whatever number is underneath this y squared and square rooting it, and I will show you that a little bit later. But actually, to very exactly make my graph for my hyperbola, what we do is we basically draw in a little box surrounding a and b, and then we have something called asymptotes, which we've learned about asymptotes before, but I have these asymptotes here and here, and when I make my graph then, what I'm going to do is I'm going to make my graph right along the rectangle and the asymptotes and then draw in my line. So make my graph right next to my asymptotes and my rectangle and draw in my line. And there is my graph. And we also have focus points this time, and kind of like the parabola, the focus points are outside of the box, I guess I could say, and my graph always opens towards the focus points. So this time they're on c, comma 0 and negative c, comma 0. Go ahead and pause if needed. I think it would be best if I just showed you an example with numbers. I think that would be the most clear. And let me also say, actually, let's fill in one more thing on our chart quick. The asymptotes that I just drew in, if I think about the slope of this asymptote line, a slope of a line is always rise over run, or how much in y it went divided by how much in x it went. If you look at this, it went b value up an a value over. So my slope is b over a. And it's going to be positive or negative because it's either up b in over a or down b in over a. And again, I'll show you with numbers, so it'll probably be much more clear when I show you with numbers. Okay, so let's go ahead and do example 1a. So the first thing that we want to do is find a and b so I can figure out how far from the center my vertices are. So we are going to find a and b and plot them. And remember, my center is always going to be at 0, 0. And we also kind of know it's at 0, 0 because I don't have anything with x and I don't have anything with y. You'll learn how to do translated hyperbolas in trigonometry if you go on to that class. Now, the a value is always the one with the positive variable. So this time x squared is positive. So I take the square root of 16 to get the a value. And that also means that because it's with the x, in the x direction, I'm going to go 4 units either way. 2, 3, 4, and those are going to be my vertex points. 1, 2, 3, 4. So my vertex points are at plus and minus 4, 0. And I want to point out that I'm also going to do similar to what we did before, where I'm going to take the square root of 4 to get my b value, and that is matched with y, so I'm going to go 2 units in each direction in the y values, y direction. But we don't call that a name. That just stays there. Step 2, you're going to draw in your rectangle. So I'm just going to make a box around these points I drew in. Step 3, we're going to draw our asymptotes. And you go perfectly in a line from the center to the corner, but it's possibly better if you first think about what's happening here. So it's an equation of a line, y equals, but the slope of this line I'm going to draw in is 2 over 4 this time, because I'm going up to right 4. Up to right 4, or down to right 4. So that turns into 1 over 2x. So I'm going to draw that line. So it starts at 0, 0 because it has a y-intercept of 0. Up 2 over 4. Down 2 over 4. And here's my other one. So I've drawn in my asymptotes. Okay? And then last but not least, I sketch in the hyperbola. And here's how I know what to do. It always gets sketched through the vertex points. So if my vertex is here, it goes through here. And then another way you can remember which way to graph it is that if x comes first, it's going to be graphed through the x-axis. Now, one thing I want to show you that might kind of throw you off is that for hyperbolas, whichever variable is positive determines which way the graph goes, not whichever one has the larger number. So you might remember from what we've been doing the last few days, if this was an ellipse, the 36 would be with the a value because it was a bigger number. That is not the case with hyperbolas. The a value always goes with whichever variable is positive. Doesn't matter which number is bigger or smaller. So the a value always goes with whichever variable is positive, even if it is a smaller number there. So let me show you what this graph would look like. So again, step 1, find a and b and plot them. Well, let me get myself set up here first. My center is at 0, 0. So under x is still the a value, even if it's a smaller number, because x is the one that's positive. So the square root of 25 is 5. So I'm going to go 5 units in each direction along the x way to find my vertices. 5. 1, 2, 3, 4, 5. So the vertices are plus or minus 5 comma 0. By the way, I just realized I forgot to find the foci for part A. Oh well, we'll do it for this next one. And then let's do part B. And actually, let's be honest here. I think that maybe I didn't do it because, yeah, we're not making you graph the foci for these. Actually, we're not, so we're not going to graph the foci for hyperbolas. We're only going to use a foci in order to solve for A or B if needed. I'll show you how to do that on the back page. Okay, the B value is 6. So basically in the Y direction, I'm going 6 units. And that is further away than the vertex was, and that's okay. That's what happens when you're doing hyperbolas. I'm going to draw on my box. And then I'm going to draw on my asymptotes. And this time my asymptotes, well, my rise is 6 units and my run is 5 units. So it's going up 6, right 5. So 6/5 is the asymptote line. Up 6 units, right 5 to get my point for my asymptote line. Or down 6, right 5. And then I draw my graph through the vertex, and I go as close to the box and the asymptote lines as I can. We have just done 2 graphs that both had x squared first. So now let me just show you what the difference is if you have y squared first. I'm going to scroll back up to our information I was giving you earlier. So now see, the thing is, if y squared is first, just the a goes with y, and the vertices then are on the y-axis instead of on the x-axis. And the asymptotes, well, the a value actually is going to be the up and down, and the b value will be the left and right. And let's draw in a quick sketch also. So this time, my vertices are going to be up and down, and so those are at 0a and 0 negative a. And then some other point, whatever it is, not labeled with a word, is b and negative b. And so I still have my little asymptotes and everything, but the thing that's different here is my graph then is going through the y-axis right here. See that? So it's opening up and down instead of left and right. And I will now show you a more exact example of how to do that. When you're ready, flip to the back and we'll do 2 graphs that show that type. Okay, so again, remember what I said. For hyperbolas, it doesn't matter which number is the bigger number. Whichever variable is positive, so right now y squared is positive, x squared is negative. Whichever variable is positive is the one that has the a and the one that the vertices go with. And you do the square root. So right now a is 2. And because it's a y value, I go 2 units in the y direction to find my vertices. So my vertices this time are plus and minus, actually pause 0, comma, plus and minus 2 for my vertices. And then to find just the other point that helps me create my box, doesn't have a name, I take the square root of the one under the negative, and that's a 5, and that's with x, so I go 5 in the x direction, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Doesn't have a name, but it helps me draw my box in. And also the value helps me find what my asymptote lines are. And again, asymptote lines, the slope of a line, like any line you've learned about since like 8th grade, is rise over run, and this is going 2 units up and 5 units over. So 2 units up and 5 units over, and that also happens to be the a value divided by the b value, and that's why we put that in our little formula chart on the front page. Okay, and now here's the one thing you got to be careful of. Remember that when you draw your actual graph, it goes through the vertices, and also because y squared is a positive one, it goes through the y-axis right now. So there I go, through the y-axis, through the y-axis. Why don't you pause the video and see if you can do D on your own, and when you unpause, I'll have the answers showing. Alright, so you should have gotten vertices at 0, comma, plus or minus 7, and the asymptote lines are at y equals plus or minus 7/3 x. At this stage, we're going to move on to creating equations. And so here's where I need to give you some key information, and that is, see how the hyperbola is very much kind of the opposite of an ellipse? And finding the focus is also the opposite of what you would do to find an ellipse. And here's what I mean. The focus point I get from finding a c value, just like I did for the other ones, but the formula for this one is c squared equals a squared plus b squared. So for a hyperbola, it's c squared equals a squared plus b squared. For an ellipse, it was c squared equals a squared minus b squared. So maybe you want to make a little note to yourself. Note, a hyperbola is that the ellipse is the one that had this equation. Now today, of course, we're going to use the equation in the box because we're working with hyperbolas. But when you get to the test eventually and you have to do everything, hyperbola has a plus sign in the middle and ellipse has a minus sign in the middle. Now, to create an equation, you saw we need a and b. So when I'm creating an equation, first I want to determine which direction my graph is going. So I'm going to determine if it is an up-down graph or a left-right graph. And basically after that, I'm going to make sure I have a and b, and then I'll just plug it into my equation. And I'll show you how to do that as we go along here. So I recommend drawing a little picture. And remember how the foci are on the same line as the vertex? And I only mentioned that at the very beginning. We haven't been graphing it. But again, the foci and the vertices should be on the same either x-axis or y-axis. So here I've got my foci at 0, 3, and 0, negative 3. And I have my vertices at 0, negative 2, and 0, 2. Okay, so clearly I can see this is an up-down graph. And because it's an up-down graph, because my graph always goes towards the focus, also it runs through the y-axis, so the y-axis is going to be the positive one. And now I just need to find what a and b are. And by the way, a always goes with a vertex value, and that is a distance of 2 units from the center. So my a value is 2, so 2 squared is 4. And now just to finish my final answer here, I need to find the b value, and I do that by using this equation I just gave you up here. And by the way, I didn't say yet, but what's the c value going to be this time? What's the c value going to be? Hopefully you said 3, because the foci are 3 units away from the center. So 3 units away, so focus is 3, vertex is 2 units away, so the, actually I should have said c is 3, and the a is 2. So if I fill in this formula here, c squared, that would be 9, and then a squared would be 4. Let's go ahead and solve for b. And actually, if you want, I don't even have to solve for b, because in order to create an equation, right here I put what b squared is. I mean, the other way of doing it is I could figure out that b is square roots of 5, and then just b squared is 5. Okay, let's do C actually, because that one's X1, and then I'll let you try B and D on your own. So we're going to do C next. Alright, so again, let's draw in the information I know. So the foci are at 4, 0, and negative 4, 0, and that's the center there. Okay, and then the vertices are at 3, 0, and negative 3, 0. Alright, so first of all, I see that this time the graph is opening like that. So because it's opening this way, and my vertex is on the x-axis, for my final equation this time, x squared is going to be the positive one, or the one that comes first. And also then, the a value, or the distance from the center to the vertex, is 3 units, and 3 squared is 9. And it turns out that the distance from the center to the focus is 4 units, so C is 4. And the reason I care is that information will help me find B to fill in under the y squared, and then I will be done. Yay. Okay, so C is 4. 4 squared is 16. A is 3. A squared is 9 then. I'm solving. B squared is equal to 7. Okay, so B squared is equal to 7. Let's plug it in. There I go. These ones are a little easier. Why don't you pause the video and see if you can do B and D, and then we'll check your answer when you unpause. And you can ask me to go through them more in class if you need to later too. All right, here's the answers you should have gotten for B and D. Go ahead and check your work and make a note of any questions you might want to ask me tomorrow. All right, thanks for listening, and we'll talk to you again soon.